You are the first speaker?
Yes.
Yeah. So I will not further introduce the speakers because we asked them to introduce themselves. So they prepare with or without the presentation. But we asked them to talk about 5 minutes to talk about the relation to projects they are representing here, and also to say something about the current collaboration they already have with FIRE, or could be also no collaboration, but okay, you will hear, and I think we are now ready for the first presentation.
Okay. So, normally I don't like to do big presentations, I like more to speak out and communicate ideas, but this time I thought that would be different from the bunch, so I decided to do a short presentation. So I'm going to present a bit on the ideas of this roadmap that we are more or less trying to work on, and relating to IoT and 5G. So just a bit of me, for those that don't really know me completely. I have a background from computer science and computer engineering, so I started as a computer scientist and moved to actually more towards engineering. So I'm a mix between software and hardware integrator, but also developing both things. I work on interoperability, I work on IoT integration technologies, middleware, these kind of things. And notably, I'm the project coordinator of the ERIT project. ERIT is an experiment on top of FIRE testbeds, so OBNet and Smart Santander. We'll talk a bit on the experience that we got there and the learning. But I'm also involved in other communities, for instance, the Excel community, so Artemis, now Excel community, developing, for instance, ROED, where we are working on interoperability and integrability. And we are part of the Fiesta project, which was presented just briefly. So we are actually responsible for the requirements, so leading on the requirements of the test bed, and also on the development of the interoperability infrastructure. So let's say that I understand both sides of the story, so both the test bed, and also I've been using the test beds in the ERIT project, so I know a bit of some good things and some limitations also of existing test beds, and I'll talk a bit on that. Moreover, so me, I basically started as a professor at the University of Lisbon, and but at the same time I moved to research and worked a lot on research on Innova, and so I can manage both research and education. So I do research and I convert the research that I do to my students, and I do pick the students up for research. But recently we also developed a company, a high-tech company, Unparallel, in order to move this research to innovation. So to actually really activate this knowledge triangle that we talk about, but we really don't do it. So we are doing it. And so some of the insights on IoT, I work a lot on IoT, and this is my view on IoT, okay? So actually, despite the intention that we've been having, and even the developments that we've been doing on IoT, we are actually not yet there. And most of the things that we see in IoT is still very experimental, and the deployments are scarce and in silos, so we are not really there in IoT. The IoT is not really keeping its promise. The question is a bit why, and we've been developing on the why of this and working on this and moving forward. And the bit of a why is that we think that the IoT needs to become something different, which is a routine, a simple thing, easy to use, easy to integrate, easy to develop, and not like today, which is not that easy. It still requires a software engineer to develop software there. Sometimes even for you to attach a sensor, you need some skills on electrical engineering and electronics, so it's not that easy. It looks easy, but at the end when you start to develop, even you get an Arduino, which is a very basic platform, there's still development there. So it needs to become much more simple for users and for other people to adopt and to move forward. So actually this is what we are more or less aiming at in our research and our innovation side. And this is the way that we perceive, or I perceive, a bit of the IoT. I'm making it very simple because I don't like complex things, and it tends to lose the attention. There are basically two functional models course, we can discuss details on this of the IoT today. The first one is the one to the left, the other one is to the right. So the first one is typically you have sensing devices, sensors, wearable sensors, whatever, and then we have gateways that or sync nodes that take data and consolidate data. This then puts the data in the cloud, and then the cloud use the applications or the interfaces. So this is typical model that you see today. This is the most common model. Even for instance, Smart Santander uses this model and other places. But you have the other model, which is the sensing direct to application, which is basically because of privacy and security concerns. We don't want the data to go to the cloud, and this is an issue. And so you have these two models, and they need to coexist. The technology that we see there, so this is more or less the today technology in the left. So basically, it's all based on communications, wireless communication. So short distance communications. Let's say 100 meters when we are talking about modes, wearable sensors. Then we still use embedded computers for these sync nodes and these devices. Then it goes to the cloud and use smartphones. What happened in IRIT, and now taking a bit on the experience from the project, was that we understood that, for instance, for acoustic sensing and for the processing that we needed, it's much more needed not only this kind of modes, which are basic modes, the processing is limited. We need to combine both the sensing and the processing. We need to have more powerful IoT devices down there, okay? And so we developed this, let's say, black box there. We call it APU, Acoustic Processing Unit, that combines both the sensing and the processing. Is kind of an embedded computer with acoustic sensing. And then, of course, it goes to the cloud, which in this case is Smart Santander infrastructure, and we use the smartphone. So we think, and my vision of a bit of the future is that we will have much more powerful IoT devices with energy capabilities that are much more efficient. An example of this is the ARM A5, which is very clear as a technology that will go for the future. We have it at our labs. We're experimenting with it. It's very efficient, very nice. So it's much more powerful than classical modes. And we see a bit that 5G can make, let's say, the links, all the links in between those communications. Maybe it would be a technology that would prevail even at the low level. We can use it and we can deploy it in a larger scale. So this might be the future. So I'm just giving two ideas for starters, then we can discuss further. Two ideas for this roadmap. So one of the idea is we need to be easily and promptly deploy and experiment at all levels of the IoT infrastructure, and I'm talking especially at the gateway level. For instance, Smart Santander does not allow deployment at the gateways. And if you want to do distributed intelligence, let's say at one local level, you need to deploy at the gateway. You need to deploy at the sync nodes, and it's not possible today. So and other test beds have the same issue. So deploying at all levels of the IoT infrastructure is important for making these new applications that I talked about. And the second one is we need to experiment with the 5G solutions, and especially when we are talking about tons of smart communicating objects. And this is where I think that the major problems will happen, and this is where maybe the test bed might help us to perform. Okay, so we can then discuss further on. This is just this. Okay.
Okay, thank you. That was our first speaker. Then I think we have Nikos Makro. I don't know if you can.
Hello to everyone. I'm Nikos Makris from University of Thessaly in Greece, and I'm giving this presentation on behalf of Professor Stanatis Korakis and Leandros Stasioulas, who were initially invited to this session. And at University of Thessaly, we have been heavily involved in several fire-related projects. We operate the NITOS wireless testbed for evaluating mainly wireless protocols. And some projects in which we have been participating are Open Lab. We have been leading the wireless work package. We are coordinating the Flex project and the Smart Fire project. And we are also part EURECOM institution which is participating. Finally, these enhancements are going to be fully integrated with the tools that already exist in the facilities. And finally, mobility, RF emulation and monitoring frameworks will be deployed. So if we take a look at the testbeds in the FIRE initiative, the wireless technologies that they currently are able to provide are experimentation with Wi-Fi resources, with mobile WiMAX, LT and LT advanced resources in macro and femtocell setups. We have mobile robots, uncontrolled mobility testbeds. Most of these testbeds have an open flow backend. We also have resources for software-defined radio-related research, like USRP devices and advanced sensing engines, and several sensor installations. How do we move beyond these resources towards the 5G? These are some steps that we have identified internally in the FLEX project on how we're going to enable a first 5G testbed, which is by creating cognitive applications on LTE, by exposing the maximum configurability of the commercial resources. We see currently that the partners in the FLEX project, the industrial partners are assisting us in this way. For example, Siran Communications, who is providing the commercial EPC software for the LT cells. They have created a new version specifically for the needs of the FLEX project, where they expose more parameters which can be configured through a JSON-based API. Finally, moreover, developing and deploying the appropriate tools that we have defined in the FLEX project, create cooperative communication over LTE. We are working currently on this field by using the LTE open source components which are available in the FLEX project. And we are trying we are examining the potential of how we can experiment in the millimeter wave band, in the 60 gigahertz band, by exploring custom-made solutions. Finally, porting of LTE entities over software-defined radios will boost the research towards 5G. An example of this is Agilent China, who has they have successfully ported the open air interface modules. Open air interface is an open platform that is used, provided by EURECOM and used in the FLEX project. They have successfully ported it over USRPs so that a vaster community of researchers can get a hands-on approach on the LTE resources. We're trying to explore open source solutions and setting up test federations for increasing the heterogeneity of the resources. So these are some the steps defined towards enabling 5G research by the network's strategic research agenda. You can find this document in the 5G PPP webpage. And from my experience as both a testbed experimenter and a testbed administrator, I believe that most of these steps can be currently achieved by using the existing infrastructure. So this is from me. Thank you for your attention. I encourage you to visit the two websites of the project. And if I can add one more thing about the FLEX project, we currently have announced the first open call. We're looking for proposals for two different types of proposals. One is for novel experiments that will take advantage of the already deployed LTE infrastructure, and one is for extending the existing FLEX infrastructure with more resources. So you can find more information about this at the Flex website. Thank you.
Thank you. So our next speaker is Carl Andersen.
Yes.
Yep. So we'll.
Thanks, Ingrid.
Yeah.
The slides should be here.
I'm not used to the.
There is a globe.
No.
That was Martin's slides.
Yeah. No, we have to open it.
Okay.
Windows anymore.
First
This
one?
one?
Yeah, exactly.
Okay.
At least I recognize the name.
I hope. So we control L or something? Yeah.
Perfect. Thanks, Ingrid, for helping out.
Yeah.
Yes, so my name is Carl Andersen. I am the second speaker from Luleå University of Technology, Center for Distance Planning Technology. I am kind of a newcomer there. Michael has been there for a long time. I started at CDT 1st of January this year, but I've been working within the university since 2005 when I stopped my industrial career within Capgemini and returned into academia. So I did my PhD there and graduated 2010. And nowadays I'm splitting my time between CDT and the Laboratory for Pervasive and Mobile Computing, where I'm associate professor. So I'm glad to be here today. I will also be tomorrow with the Japanese friends. I was at NICT last year on a scholarship working with mobility solutions. So I was the first guy I met. It was Aseda-san from NICT. So I will be one of the European rapporteurs tomorrow and on Friday. So that's good to combine these events. I'm just briefly going to speak a little bit about the experimentation and piloting environments we are hosting up in North Sweden. I'm quite sure many of you heard about the Botnia Living Lab, one of the first wave living labs actually. Also we have the IoT Innovation Lab that we launched a few years ago. I'm not going to go into the details of the Botnia Living Lab, but it's a big community, over 6,000 users that we have access to, and we do a lot of projects around that. The IoT Innovation Lab was created in order to boost the future internet by real-life testing in challenging contexts. And what could that be? Well, it could be both smart cities or smart regions. We were active in the Firewall project. We have had a regional project in smart cities where we have developed a few prototypes on environmental monitoring and everything from smart storage to smart stables or things like that. And you heard Martin's presentation on organic cities. We were instructed to call it H2020 grant under preparation, so we really hope everything is going well, Martin. So we are hopefully going to be on that project also. We're also an affiliated partner of EIT ICT Labs, so we are quite active in that community, most notably working on efficient IoT content, which is very much related to smart regions and smart cities. Also one concluded FP7 project is the N4C project, Networking for Communications Challenge Communities, Architecture Testbeds and Innovation Alliances. That was mostly performed in very rural areas like North Sweden and other parts of Europe, where we really tested new exciting things in extremely rural, under extremely rural conditions. We had also Google on that project with Windsurf coming to North Sweden, doing really exciting experiments. He has an honorary doctorate from our university, so I think that's one of the reasons. We're also on IoT Lab, ERIT, Amplifier, of course, and on the national Swedish level, we are also one of the founders behind the Swedish Strategic Innovation Program on IoT that was launched this summer, actually. So we're very active. What I want to emphasize here is the 5G research we are also doing. This is mostly done by our researchers in the chair of signal processing. So we are doing file modulation, coding, OFDM of multiple access schemes,
Also LTE standardization duplexing schemes on the wide side with XDL technology, channel characterization and measurements. And we're doing this type of research in 4 areas. Channel characterization for machine type communications. I will show you a few examples on the next slide. Modulation and waveforms for low out-of-band emissions. And then most notably solutions for 5G extreme rural coverage. And then also we are setting up a lab on software radio for rapid prototyping and demonstration. And this is how it could look like. We are active in a fairly active mining district, although the mining prices are now declining, so we see some economic problems. But this type of 5G communication would really help out there, mounting sensors more or less everywhere and feeding systems with timely, up-to-date information. This is the rural side of it, where we are working on both standardization and experimentation on 5G for extreme rural coverage. If you take the railway from Luleå up to Norway, you will pass this valley, Lapplandsporten, where we are doing experiments with upcoming 5G technology. And here is the software radio lab that I spoke about. So the aim here is to combine this 5G research that we are doing together with the quite long-lasting research we have been doing on smart cities and smart regions. Hopefully we will have interesting discussions on that and persuade the Commission to put some interesting calls up on these areas. Thanks.
Thank you. So, and I think this is exactly what our next speaker, Bernard Barane, will talk about IoT and 5G in Next Horizon 2020 calls. At least this is what we expect. So,
you have where do
you do have a presentation.
No, I just this belongs to Nikos. But you should offer him a new one because he is owned by DDT.
Yeah, I might.
Only 3 slides. It's only 3 slides.
Yeah, perfect. Thank you. Good.
Okay, thank you very much, Ingrid, and good afternoon to all. So I'm Bernard Baranier. I'm a Deputy Head of Unit in the unit E1, which is dealing with network technologies. So that's the unit where we are, let's say, running the 5G PPP initiative and the IoT initiative. So I will try to tell you as much as I can because you know that the work program is still under discussion at this moment in time. There have been no precise decisions which have been taken neither in terms of content nor in terms of budget. So all this is still in the making at this moment in time. So I just can tell you what are our thoughts, orientations, ideas, but I cannot tell you that this is firm and cast in concrete at this moment in time. But what I can tell you are the boundary conditions under which we have to operate. And first, I will try to start with the 5G case. The 5G case, we are to a certain extent bound by the roadmap which has been presented to us by the 5G PPP Association or by the forerunner of the precursor of the 5G PPP Association. When we signed last year the contractual agreement to launch the 5G PPP initiatives, was attached to the contractual agreement, let's say the main phases that this 5G PPP should have to respect. So we are now with the current work program, which is open until the 25th of November for the ICT 14 call. We are now in phase 1, which will be primarily a pure research part, where we have a number of topics which are open for research proposals and one topic under innovation for a total budget of 125 million euros. So this is what is in the current work program now. And we are now discussing the second phase. The second phase, according to the PPP Association proposal, was something which should be more already oriented towards demonstration, test, or validation of technologies. So this is the type of, let's say, reflections we are having now. What type of tests, what type of demonstrations, what type of experiments, what type of trials. Now, in this overall discussion, there was also in the PPP proposal a proposal to dedicate in the second phase about, if I remember well, 75 or 72% of the budget for research and the remaining part, 25% or so, for innovation. So we are now trying to work within these boundary conditions. Extra boundary conditions that we have to respect, especially if we think in terms of experiment and test, we have to respect the international agenda. This is not a Commission slide, it's a slide which I have borrowed from an Alcatel presentation which was presented at the consultation meeting we had last September. But what does this slide say in a nutshell? It says that the 5G community does not expect precise standardization discussion to start before what is called in 3GPP release 14. Release 14 covers more or less 2016-2018 timeframe. And they expect, at least that's what is more or less agreed by the community, not all of them, but more or less, they expect that precise standardization work will happen under the timeframe of release 2015, which is covering 2018-2020. Knowing that the 5G PPP altogether targets product availability beyond 2020 timeframe. So if we start thinking in terms of testbed demonstrations, we should try to align with this international standardization agenda, which is also coupled to an extent to the international spectrum decision agenda. There will be an important World Radio Conference in 2015, which will probably, we hope, put on its agenda for the next conference in 2018, because each conference decides, each spectrum conference decides on the agenda of the next conference. So in 2015, we hope that there will be a decision to put on the agenda of 2018 the spectrum requirements for 5G. That means how do we extend or don't extend into millimeter wave bands or into the kind of things that was alluded before. 28 gigahertz, 60 gigahertz, 90 gigahertz. There are a number of bands which are being contemplated at this moment in time for possible extension for 5G. So this means that in our view, if we go for test beds and trials, we have two possible routes to investigate. First, a pure technological route where whatever we put on the table contributes to the standardization agenda or contributes to the spectrum agenda. So that's one possible route. The second route is the use case route. We have heard in many places, in many forums, that 5G will support much more efficiently than today verticals. Automotive, intelligent vehicles, automated driving, energy grids, environment. So there is a number of use cases which are associated to IoT type use cases, but also mission critical type of IoT cases which are driving the performance requirement towards 1 millisecond latency and this kind of things, which is, by the way, driving the requirements for control plane, data plane decoupling that was presented by Ingrid Monmans in the previous speech. So there are a number of things which are correlated here. If we manage to set up test and validation activities in the next work program, we should also try to involve as much as possible the verticals. That means to go beyond the usual so-called usual suspects, the pure ICT type of industry, but try also to demonstrate that whatever we are developing for technology has a use case in the automotive domains, in the sport domain, for instance, the high density type of scenarios which is contemplated for millimeter wave could be trialed in stadiums or in train stations where there are high density of people. So basically, two routes for reflections. One route which is purely technological to validate standards or to prepare for standards or to prepare for spectrum type of discussions. Another route which is more use case type of orientation. Now, this being said, we have a full 5G agenda to think of. So at this moment in time, what we are thinking of, but this is still between brackets because we don't know what is the proportion in terms of percentage that we will dedicate to the various activities. We would like, or we are thinking of having one block which will be a pure research block, which will be the continuation of the research activities that we believe are more longer term. For instance, radio architectures or network protocols. So these are things which probably will stay in the research domain. We have the second block, which I just described to you in more details because you are coming more from the experimental and testbed side, where we will try to develop these notions of test case or testing or demonstration type of activities. And we have a third block, which is related to innovation, where our thinking at this moment in time is to try to investigate if we can take SDN, NFV as a focus type of activities for that, and try to develop sort of virtualized network functionalities repositories that the community can use to assemble virtualized functionalities to provide services. So this is one route we are thinking of also to move more in the innovation domain for the next phase. And this phase would also have an experimental, let's say, an experimental type of flavor, because it very much resembles the type of things that FiWare is doing in another context. So that's so much for 5G. IoT has a different logic because IoT has already several years of research activities behind us. So 5G is more long-term. We are thinking of 2020, even beyond 2020. IoT, there has been a lot of research which has been carried out on this subject. And here, the basic intention is to try to move IoT more into deployment, into the deployment phases. So to that end, we are trying to structure the program around what we call large-scale pilots. These large-scale pilots are not defined today. So it means that we don't know in which sector, in which particular use case or particular vertical we are going to implement these pilots. Could be in smart homes, in smart health, or in I don't know what. So there are various views on that. The idea would be to have some sort of reference implementation scenarios that can be convincing enough to prove the capability of the technology for mayors or in cities or in dedicated application scenarios. Because IoT is extremely complex, there are many stakeholders and there are many, let's say, possibilities of implementing IoT systems. In particular, there are many standards which are applicable. So one thing we would like to do is that we would like to push the demonstrability of the technology through use case, and at the same time we would like to underpin these use cases with work on platforms in the sense of FiWare type platforms. That means that we would like to push the capability of the platforms which are available in Europe to show that these platforms are compatible with a huge collection of use cases. So it means working further on the evolvability of the platform, working further on the possibility of the platform to implement reference standards and to implement reference implementation for standards to serve a particular use case. And this would be accompanied by what we call residual research. So we have identified already that there are at least two topics that would deserve further research, which is semantic interoperability and end-to-end security, which are at least two things we believe deserve further research. And then horizontal issues means applicability of standards, defining reference profile for standards, and also defining reference implementations, possibly in open source. So this is the status of the reflection at this moment in time for the IoT side. As you see, it's more applied towards implementation and deployment, but I'm not sure it gives you a very good picture, but that's where we are at this moment in time. Thank you very much.
Okay, thank you. So I think we had a very interesting introductions, and we are now open for discussions. Maybe because I didn't give you the opportunity, are there any direct questions to the speakers from the audience? Yes? Can you put on the mic? Ah, you don't have one.
Yes. two practical questions to Bernard Barani regarding the 5G PPP. The first one, how do you estimate the first phase? Is it a 2 years project, 2.5 years, 3 years project? Just to have a clear idea in terms of timing. And the second question, how do you see the synergies that can be developed between the phase 2 of the 5G PPP and the fire resources and testbed environment?
Bon, I expected this question. Bon, in terms of duration of the projects, well, we don't have any religion on that. Our typical projects are 2 years, 3 years. It seems that for a program which is being sliced into 2 years phases, having projects which are framed by 2 years duration or 2.5 years duration seems to be a reasonable compromise. Also taking into account that the current definition of large-scale projects is in the order of 5 to 8 million, which is a little bit smaller compared to the IPs that we had in the past. So this also tends to reduce the time span of the duration of the project. So again, no particular definite answer on that, but it seems that between 2 and 3 years is something which is reasonable, and which is also in line with the fact that something which is very important is that we want to design this PVP not as a set of independent projects. One project on commodity radio, one project on blue antennas, one project on red antennas, and so on. We want to define this as a program. So that means that the projects will have to be linked with each other, very much the same as it is done in the future internet PVP. So that means that we expect that there will be a sort of collaboration environment across the project. So it means that we have an interest that the projects have more or less the same duration and the same time frame. So that's the reason I call this type of duration. Now, in terms of relation with the fire activities, I mean, it's a little bit difficult for us to answer that question. I mean, at the end of the day, it seems to us that the answer lies very much in the hands of industry. I mean, the 5G PPP is something which is industry-driven. So whatever we do has to be to serve the purpose of industry, either an existing industry which we reinforce, or a nascent industry which is not yet there, but which we help to emerge. So this is typically the case for the SDN and FV, where our intention is to help Europe to support the emergence of players in this domain, which is very competitive, but which is also very much software-driven, so where the market entry barriers are lower. So if the market entry barriers are lower, the opportunities to get into this business are higher. So we have to understand what is the best testing and environment scenario that reflects the impact and the potential usability by the industrial players. And this is our driving force at this moment in time. We know very well from the past that some parts of the industry are very much, I'm very open here with you, some part of the industry is very much against the idea of running test beds in collaborative projects, in European collaborative projects. Some part of the industry say, if we do a test bed, we do it ourselves, in-house, and this has nothing to do with the collaborative project, but there are plenty of problems with IP sharing, with sort of how you exploit the result. So we have to find a framework. We have some ideas for that, but we have to define a framework where we can be at the same time useful to the industry, and we can at the same time show that there are some results which are coming out of this program. And one of the reasons why we want to move into testing and experimentation is that also from the pure political point of view, we cannot say that we are going to spend 700 million euros on paperwork. We need to show something. We need to show some test beds, some experiment that shows that something works. So we have some ideas on how to do that. Now, our best support would be to try to find the testbed environment or the federated testbed environment. I don't know if federation makes sense in that particular case, but the experimentation environment that provides maximum impact and maximum visibility for industry-led type of outputs. That's the only answer I can give you at this moment in time.
Thank you. Are there any other questions? No? We also prepared for this session a few questions, so maybe we can start from these questions for the remainder of the discussion. I hope I can find them from the laptop. Okay, so we prepared 3 questions, but I think we can start with the first one. And this is what does your ideal IoT or 5G testbed look like? For example, in terms of hardware, software, supporting services, whatever. What is expected? And of course, testbeds will always evolve, but what is needed today? And what will be needed, let's say, by 2020. And I was actually thinking about our first speaker for the Internet of Things. I remember in the last slide you mentioned something, 5G is an enabler for Internet of Things. So what did you mean by that? Could you be a bit more concrete?
Yes. Just trying to answer directly here to the ideal testbed. I think that it should be really something where the practical use of 5G and IoT is very clear. And this is already one issue, because when we are talking about IoT, we are seeing today that we are using IoT, or even deploying IoT, or even doing test beds of IoT in some areas and doing some applications that practically there is no business case for that. So it means that we need to focus on few things maybe, but those things that are real of importance and real things that will, at the end, we can get leadership and you can get real good technology out there. So this is one of the issues. This is a big discussion that we need to have first, and discuss what are those areas, and maybe sometimes we need to avoid a bit the classical areas, so because some of the things really don't apply. Okay, if you want to measure an example, if you have a test bed where you have a temperature sensor and an humidity sensor all around the city, I doubt that you want to know the temperature here at this point, and let's say 100 meters there, another 100 meters there. So it's nice, it's a technology nice to have, but at the end the application is not there. So things like this are happening even in fire. So I think that we need to move away from that. We need to discuss very profoundly what are those applications and try to develop technology and testbed around that, right? Because sometimes we say that we should deploy a testbed without a purpose, okay, that is for sure. But when we do that, we tend to do a testbed with no purpose at all. So we need to focus a bit on purpose for deploying a bit on the testbed that makes a bit of sense. Okay, so this is a discussion that we need to have. Of course, I have some ideas we can share. So the ideal one for me is the one that makes sense. Okay, so we need to discuss that first. So I pass on.
Well, maybe I just want to interact because I think it's indeed a good thing that testbeds are purpose-driven. One of the challenges in Internet of Things is also interoperability. If it is too much purpose-driven, don't you have the risk that you end up with even more vertical solution instead of interoperable solutions?
Well, we have a Fiesta project dealing with that, so you can experiment there. It might be true, but sometimes it's better that you try to experiment on things that make sense, and if you have interoperability problems, we solve them. I work in interoperability for more than 15 years, okay? And if you ask me directly if there is an interoperability problem in industry, I might respond that no. And why? Because when you have an interoperability problem in industry, the 5-10 people that have the problem, the big ones get together, solve the problem, discuss, get in the table, solve the problem, and you have 95% of the problem solved. Then you have 5 or 10% of the problem non-solved, and that is different. But at the real core, most of the times you discuss and interoperability is solved. In the IoT, that might not be the case because you have a lot of manufacturers, you have a lot of protocols, a lot of standards, so the thing is a bit different. But at the end, possibly interoperability can be solved easily with some discussions. Okay, and then we go with the research side of the story and all that to do the other 10-15%, let's say. But okay, interoperability is a problem, but might not be a problem, I think, eventually at the end.
Okay, thank you. Is there anybody else who wants to come into the discussion? Yes, please.
My name is Kees Lanaat, University of Amsterdam. So, as you rightly say, Internet of Things are many players in the field. So there you cannot sit together with 5. So one thing to solve that is, of course, virtualization capabilities in computing, in storage, and in communication, and in your antennas. So an ideal testbed might look like having virtualization, so VM capabilities, or mini clouds on the antennas, so to say, so that from that layer on you can do the experimentation, and you don't need to care about interoperability within the applications. They can create their own environment in the VM part. So an ideal testbed would be a very close cooperation with computing, storage, network virtualization with antenna virtualization and programmable antennas.
Sitting together the 10 people, that the antennas and all that, and discuss, and inside of a group, which will solve at the end interoperability, because the other solutions sometimes is so complex, and it works. The semantic interoperability, we know, I've been working on them. It's nice, there's research, but it's so complex to put it to work that sometimes you don't really see it in industry. We do the research about it. We think that eventually we'll get it to the industry, but right. So we need to be. I think we need to be a bit more pragmatic. My understanding is very easy. We take too long in Europe to do things. Too long. Let's say to them long to be practically a bit rough, because we discuss, we foresee future in 15 years time or more, and we discuss, and then the Americans, in each time Apple talks, each event Apple has, changes everything again. They will talk in, I think, few days. Let's see. Last time tomorrow. So let's see. Tomorrow we see. So they change again the setting. Last time they introduced Health Kit, Home Kit, 2 kits. So 2 kits changed everything again. So every time they talk, they change the scenario. So we are discussing things from 10-15 years point. We have a problem because they are changing. That's like we are trying to hit a moving target, and the one that is moving the target is the Americans. It's a bit difficult. We need to. We need to do research for sure, and I agree with the research, but we have to get more pragmatic and do it a bit with purpose, okay? And even the test beds have to be a bit more pragmatic, okay?
Yes, I think the key word here is flexibility in order to speed up the processes, using test beds way more flexible than we have been used to do. So having really reconfigurable networks with cloud-based ready access networks, and where it's very easy to involve end users in very flexible ways, I think is key. And also having these domain-specific applications for 5G, that would be my kind of holy grail, as you said before.
Thank you. I think just a little bit back to the questions and try to not to be too dispersed of who is the winner on this. In the 5G, I still remember when we were discussing 10 years back in the software-oriented architectures, approach. And we said, yeah, when we start to design, or when we start to consider security by design, we will succeed with the products. In the 5G, it's well known that if we start from the beginning to design privacy and security and interoperability, that will be the killer app for 5G. But in the other side, in the IoT, we are talking about that we already have that semantic interoperability per se. Are we not talking about the same with different words? And the IoT 5G, I don't see any difference. I just see the convergence of technology and systems. It's my personal perspective trying to understand what is the 5G approach, because everybody thinks that 5G is the solution for all these silos in the integration, while in theory or in practical point of view is more convergence when the technology reach the data or when the data reach the technology. And this convergence is something that hasn't been even discussed and is not part of the applications at the moment. So coming back to the questions, which is very common to see, what is the ideal IoT 5G dependency convergence between technology? What is the division between the 5G and IoT communities, understanding and common agreements? What role do you think FIRE as a program should target is precisely this convergence as a solution, not as an option? Because nowadays it's an option. I think we should target this one as a more coordinated activity.
Okay, thank you for all the feedback on this first question. We still have 2 more questions, but I don't know how much time we still have. Is there anybody? I have no...
Yes, we are time, but try to finish in 5 minutes.
Okay,
10 minutes.
okay, I think it's good to continue the discussion, but...
shorten the break a little bit.
Okay, fine. If everybody is happy with that. Push.
I just wanted to make a comment on the previous comment. We are all in a difficult situation to define 5G at this moment in time because there is no agreed or commonly accepted definition of 5G. What we can see, what are the drivers, and IoT is certainly one of the drivers, we can see the drivers of the evolution of the networking platforms. And there are 2 types of drivers that can be 2 different categories. And this is well reflected, by the way, in the ITU document, which are now being drafted, which is called the IMT Vision, the document of ITU, where you have 2 classes of services. The first class of service corresponds to the traffic that exists today. So if you look at the usage of networks today, with social networking, emails, web browsing, whatever type of things, the growth of this traffic is putting constraints on the infrastructures, which pushes the vendors or those guys who are in the telecom business to have some reappraisal of the infrastructure in the long term, with issues such as densification of the networks, more flexible radio access, new spectrum to find new capacity because the traffic is growing. So this is the first class of, let's say, underlying type of problematic that you find under 5G, which is really a pure telecom problematic. The traffic is growing. The technology and the architecture, the networks are not so much adapted in the long term to cope with the traffic. So you have to find new architecture that cope with this traffic. That's very simple. The second idea is the idea that network will have to support new classes of services. And this is where the IoT type of story comes into play. The IoT type of story is looked at, again, from the ITU documents, but also from some research projects in Europe, has 2 types of classes from the network perspective, because in the reality of IoT is much more diverse than 2 classes of things. One which is non-mission critical, the other one which is mission critical that imposes more or less instantaneous type of response. And this is where this type of instantaneous response puts additional constraints on the network. Now you may want to ask me what market, it's a small market, there is no business case. Or, okay, this is again the next type of questions. I cannot answer that. But the problematics which are being classified are classified around this basically three type of blocks for IoT being part of the 5G problematic. Now, when you look at how efficiently IoT type traffic can be served in the 5G type of networks, the answer that you get is through SDN/NFV type of implementations. Because what people look, again, from a pure network perspective, not looking at the application, but looking just at the traffic and the networking requirements, what people look at is that the variability of the traffic which emerge from sensors and from IoT platforms imposes that if you want to keep control of your resource, imposes that you have very agile and very flexible control of the resource that you allocate to the various sensors which are communicating. And this is something which in principle NFV is supposed to deliver. This type of ad hoc reconfigurability of the service on the fly and even during session is something that NFV is part of the promise of NFV/SDN. So all this is part of a global picture. You're right. There are different points of synchronization, but you're right in saying that there is no IoT on one side and networks on the other side. But the way we try to split it is that IoT is more on the application side at this moment. What is specific for IoT is more on the application side. But from the pure networking perspective, yes, we have to consider this as a common block. That's for sure.
Okay, thank you. So maybe just a few minutes and then we have to stop. I would like to jump to another question which was also partially tackled in the presentation of Bernard Barani. That was about the open testbeds because I think you said, yeah, some industry, they want to do experimentation, but they don't like to do it on an open testbed. So what is the general vision within the 5G IoT community? I don't know, maybe in the audience, if there are more people from industry who can either confirm that they don't like open testbeds, or they say, okay, we don't care, open testbeds are nice because they are maybe more advanced than other testbeds. Are there any opinions on this question? Looking to the audience now, I don't know. Nobody dares. Or from the panel, if just to start or trigger the discussion.
Maybe there's nobody from industry here. I'm a bit from industry also, and the way that we test things is yes, we have this in-lab tests, and we do in-lab tests for sure, and then we go into the wild and we try it out in a controlled environment. Controlled means we control all the parameters, the functional parameters, and especially the security of the tests. Means that few people have access to very key technology that we develop, and we are developing it. So open test beds is a bit nice for sure, but it's a nice idea. It's a bit like open data. Same thing. Open data exists where? Possibly open data exists in public data, because you don't get to have more data than that. So possibly if you have an open test bed, you can do experimentation related to public services and public things to some extent. So possibly businesses that have core technologies and have this interest to keep it in a closed loop possibly will not use open testbeds to fully, I think.
But open testbeds, I think, as I understand it, also means that it is open for anyone. But do I understand correctly, if from an experimentation or from a facility owner point of view, if you offer testbeds, that you also should secure experimentation? That is something that, or no?
It's like the photos of the celebrities that went on iCloud. It's all secured, but then at the end, the photos are there.
Okay, I would say one final comment by somebody, and maybe, and if not, maybe we can further discuss then during the break. So thank you for participation.